Welcome to the April 27th OMR Architecture Meeting. Today we have two compiler topics to discuss, both our new IL opcode proposals. So the first, Gita will be taking us through her proposal for some new vector IL opcodes. So Gita, whenever you're ready, take over.
Okay. Thanks. Yeah, thanks. Let me share screen.
Sorry?
Okay, can you see that GitHub? Not yet.
Not yet, no. Yeah, it's starting to come up.
Yeah, great. So yeah, I don't have slides. I have just comment like in a PR. So yeah, today I would like to present a new bunch of vector opcodes. We already have quite a few, and I think it's called file like vector opcodes.enum. And this is just a latest sort of bunch for now, and it's motivated by a vector API, Java vector API, which we want to implement support in OpenG9. So we need this opcode. So when I say, for example, invocation, it's like vector API invocation, just to illustrate how you can sort of start using those opcodes. And the AVBV stands for vector. It's kind of, you'll see it's pretty intuitive. And opcode starts with VM. It's like mask version. So we have like, I don't know, like maybe 20 altogether. So we'll go one by one. So, for example, first two, V bit count and VM bit count. So it's counting bits for each element of the vector. It's a lane-wise operation, unary. That's how it's invoked in vector API. And here's like optional mask. I forgot to put it here. It's only for non-FP types, and it's equivalent to calling integer bit count or long bit count on each lane. And smaller types get promoted first to integer type. So any question about this too? Kind of, yeah, these are the names, bit count, which seemed like to be pretty descriptive.
I'm just checking to see, like we already have some bit count opcodes, don't we?
We
Just
do?
checking to see if they're named the same way, or am I thinking of something else? Maybe that's population count, which is the same thing, isn't it? Probably.
Maybe like.
Yeah, we have pop like IPOP count, IPOP CNT and LPOP CNT opcodes. So I assume a population count is the same as a bit count, or is there different functionality there? I think pop count just returns the number of ones in that length.
I think it's the same. Yeah, I didn't know. So pop count, why pop count? Pop CNT?
I don't remember the history of how it was introduced. I would guess that it was introduced because it maps to a particular hardware instruction on one of the architectures. I know Intel, for example, has a pop count instruction, so maybe that's why it was named that.
It's not an unusual name for the operation. I think it's a relatively common thing to call that operation.
Yeah, I guess what I'm getting at here is that if we're doing, we should, I think, strive for some naming consistency here.
Oh yeah. I just didn't know. I didn't know that we have something like that. Okay. You think it would sound better, like so? V pop count then, right? V pop count.
I'm not saying it would sound better. I'm just saying it's more it's consistent.
Yeah, more consistent.
Doesn't sound too bad, I guess.
It's just this looks a bit more kind of clear, right? Bit count. Yeah, like I don't know, like do we really need to be consistent? I guess that's the question. Maybe better to rename old ones.
Well,
yes.
I mean, I'm fine either way. I don't mind the population count one, and they're already in the code, so I guess I would lean more.
Sorry, Daryl. One thing with bit count is that it doesn't necessarily convey that it's ones that are being counted. I mean, zeros are bits as well. So
Right, I see. Okay, population. So you know what? Yeah, let's do that. Like vpop count then. I will rename vpop count. Okay. We can always discuss. I will modify and let people review that PR. Okay, so maybe we should move on, right?
Just one question, probably quickly answered, is when you say types, you mean probably the argument types are non-floating point, but the return type is probably an int here. Is that right?
Oh, yes. I meant like element types, vector element types. It is a vector operation, right? So,
okay.
Yeah, so both are integral types, input and result, yeah, for each element. It's lane-wise.
Okay.
Right. So I guess if you ran this with a vector of bytes, then you would get back a vector of bytes where each byte is, between 0 and 8.
Correct, yeah.
Yeah, okay.
Yeah. All right. So compressed. Compressed is it's a cross-lane operation. Its details are it takes mask. We have vmask type, so it takes mask, and essentially it tells you which elements to pick. It's kind of like, for example, if you have vector, every other element is set to. Sorry, mask indicates that we should pick up every other element, right? So those elements will be picked up and placed into the most significant, sort of to the left, significant position, or like to the left, like compressing vector, essentially, according to mask. So unlikely we have something similar already, I doubt, right? Compress. Let me check just in case. Yeah, probably not.
I think there's I don't know that we have an opcode for it, but we had some trees that were targeting an x86 instruction, which was called like parallel bit extract or something like this, which was a similar thing that worked at a bit level on integers.
And it's of course typical vector operation. It would, because you collect elements of vector according to mask. So I would keep it compressed. But if there are other proposals,
Yeah, that seems fine to me.
yeah, I think it's pretty intuitive. And expand it's opposite, like it's opposite. Like when you have it's actually opposite operation. Again, takes mask and places, first whatever, like first elements. It takes, kind of opposite operation. Yeah, it described here. So I called it vexpand. And it's cross-lane operation. It's for all element types. It's element types. So compress, expand. People can always comment on PR as well, right? Like, because I just afraid we might not have time. So another one is, here we have different opinions. Like basically it's shift left. It's shift left. 1 second, sorry. I think I missed something. Expand.
Okay, so that's another one that's got
Yes.
symmetry with the scalar operations. Do you want like VL?
Yeah. So actually, Brad also commented on that. So should we call it SHR? I think it's called LSHR. Sorry, SHL.
That seems reasonable to me.
Okay, sure, yeah. VSHL, right? So it will be VSHL. Yeah, that's, I think that's makes sense. Yeah. So, and then it will be VMSHL. Shift left. Oh, sorry, it's right. You see, I keep confusing this guy. Okay, so it's sorry, this one. Yeah. So shift left will be VSHL and VMSHL. So let me write down. And okay. And then there is separate one by constant because it's more efficient way. There is a method in vector API that takes a constant. You see, like not the vector constant here, and so that we don't need to broadcast it. There are sometimes instructions that can. There is sometimes hardware has instruction that shifts every element by constant, and actually different. It's implemented a bit differently, so we added like separate. So it would be then VSHL const, VM SHL const. Is it okay?
So this wouldn't require a constant at compile time, right? Would it?
This is a compile time constant, this one.
No, what if it's not a compile time constant? Like, I mean, lane-wise can't guarantee that, probably.
Oh, so it's a, oh, you know, you're,
Or is it only constant in the sense that it's the same for every lane?
yeah,
But
I'm
it could be
sorry,
like,
actually,
you know,
very
any
good
integer
point,
from
yeah.
a
It can
register.
be, it's a scalar, I should have said scalar, yeah.
Okay, I think it's maybe misleading to call it const
Yeah.
if it doesn't have to be a constant.
Let me think a little bit, like, yeah, I
As
think
far
it
as, you know,
means,
like the way that what we normally consider to be a constant in the JIT compiler.
Yeah, that's a good point.
yeah.
In this text here is the variable C. So for that the text that says equivalent to a shift left n, should that n be a C?
Oh yeah, it's well, it's just a function kind of for each element. Yeah.
Yeah, well, I'm just trying to make it consistent with the.
But here you see we also say n, right? So we kind of it's just a function.
Maybe that one's wrong too. I don't know.
Well, but you don't have. No, it's how can you say because
sorry,
this
I'm just
is.
trying to be precise here about what we're like how you're describing these the operation of the opcodes. Just want to make sure that we.
Or it's documented.
Yeah.
Yeah, but you see, this is a vector, right? This is how do you specify element of a vector? You know what I mean? Equivalent to n. Then I have to say n is element.
Okay, well, you've
Corresponding
specified the
element.
element of A by, you've denoted that by A. So you could say A shift left by B.
Where A and B are elements of
AV and BV.
AV, BV. Yeah, okay, yeah. So here the same thing. I can say where I can put C. Yeah, you're right. I'm just trying to think: is it constant or just any scalar? Yeah, I think very good point. Yeah, it's just scalar. Yeah. So what should we call it then? Shift scalar?
Well, I guess first, you probably want to change the name to be, you know, in agreement with the other one that's not using scalar, right? So there's VSHL now.
Yes.
And then this would be VSHL, and then I think scalar, that would make sense to me.
Scalar. So
Is that scalar always an integer? You said broadcast int here. Is that always a int?
I think so. Yeah, I'll double check. I think so. We can call VSHL int.
Well, no.
Or
I guess
scalar.
to be consistent with our typing, it would be an I rather than an int, like V. But then that conflicts with our indirect opcodes. Yeah.
Oh, no,
So
Yeah, but
definitely. No, not I, of course not, because
we want.
it's a different meaning here.
And
Yeah.
I don't think
Scalar.
that sorry.
Yeah, go ahead. Yeah.
I don't think that we usually include any part of the name that tells you the type of the shift amount in any of our shift opcodes, right? The shift amount, I think we just treat it as always
No,
being
we have
32-bit because
No, I
it's
guess
a very
he's
small
talking-
number.
He's talking about the second argument
yes.
to the shift, which is the shift amount. That he's right.
Yes.
It's not.
Yes.
I think in this case, maybe we should not compare to our regular shift opcodes because it's specifically, you see here, it takes vector. It will have two children and both are vectors. And here it's just saying that one is vector and one is scalar. So it's, you know, in opcodes that we have already, that's always scalar, right? Here it's like versus this one, kind of saying it's scalar.
Is that an argument for BV and BS or some other combination of letters, like denote what each operand is? What the category for each operand is?
So
Kind
BS,
of,
Or is it the result, I guess, is the only, which is the,
V stands just any vector operation, I would say. It might sometimes it returns in some other cases. I think it may return scalar, but we still call it V. V, it's everything that has to do with vectors.
you just put broadcast at the end of the name to go with intrinsic there.
Sorry, I missed that broadcast.
Well,
Instead of
or
scalar, that's what the suggestion is.
Scalar, yeah. I would say VS shift scalar. A little bit long, I don't know. Yes.
all right, sorry, I'm not sure if you caught that suggestion from or
Yeah, maybe I didn't. Something about broadcast.
it was that this amount is the broadcast of the of this scalar. So maybe you should say use broadcast in the name rather than scalar. So sorry to whoever was suggesting that. I think I interrupted.
All right, good. Yeah, I missed it. Yeah, intrinsic call broadcast. Shift broadcast, SHL broadcast.
Although broadcast isn't called broadcast in the IL, right? It's called splat, I think, or something.
BL shift. Splat. It is shorter than scalar.
V shift kind of sounds V shift splats. Yeah, kind of consistent, right? Yeah, shorter than broadcast. Yeah, V shift splat. Kind of. Let's go with shift. I don't know. Shift SHL splat, and then we can get back to it. Sort of think about it. Unless
Sure.
people object strongly.
Go with that for now.
Yeah, let's
So
go
I guess
with that.
is shift the only one that's going to have this problem, or are we going to have to deal with it for every combination? Like, are there
No,
going to be?
shift and rotate have such thing. Shift and
Okay, so we don't
rotate.
have a splat variant of other kinds of opcodes to deal with,
In that sense, like shift.
like a vector add, for example, can't be a.
No, at least. Yeah, it's a good question, but interestingly, in the library there is no such thing.
Is there a?
Library
there
will
a-
invoke broadcast itself.
Okay, so let me. Sorry, I came into this conversation in the middle, so forgive me if I talk about something that's already been discussed or say something stupid. Probably more the latter. Is there a reason why we need to have a vector left shift by a constant? If we so it goes back to my other question.
I like where this is going.
If I have a vector add, is there a vector add splat version that does a vector via a scalar, or is it that you splat a constant into a vector and do a vector add on it with the vector?
The latter. Like library will do, for example, there is method in the library that takes like constant, add constant, but library itself will do broadcast, and which will translate to splat. So there is no such thing. But interestingly, for shift and rotate, there is special intrinsic, which I think probably because there are instructions like that. take advantage of instructions that shift and rotate by
Okay, but is
constant.
that something that the evaluator could deal with versus the optimizer having to be exposed to it?
Like we could represent this as a combination of the two, where the shift amount is just the splat of
Right.
what was passed in.
Right.
And
Yeah,
then
but
we could generate the good instruction whenever we see that.
oh, we were
Yeah.
thinking about that. Yeah, but sometimes, you know, for example, how to say, yeah, I suspect that just shifting by constants is cheaper than broadcast and then shift. But we can't always detect it, right? For example, something already common, like somehow it got into register, right? Like that.
Well, if it's already in a
We
register,
cannot.
then you needed to splat it anyway, right? For some other
If it's
reason
already
earlier.
in a register.
I mean, I guess you're tying up a register that you don't need to, but I mean, like we could find those opportunities if it was important.
I guess why does it matter for shift but not for add?
It just
Because there's an instruction.
because instruction, yeah, because I think Intel has an instruction that shifts by constant.
Or I guess maybe more likely than add might be multiply by a constant.
Yeah, that would be another. So is that purely an Intel statement? What about power? What about ARM64? What about?
Like to be honest, we didn't check all platforms, but on
Nobody has
Intel
an
and ARM, I think Intel and ARM, I think have specific instructions. I think, yeah, if I remember correctly, they have specific instructions that are cheaper than doing broadcast. And of course, we can do it recognize an evaluator, but somehow.
But it's an optimization, right? Like it's a very local optimization in a sense. Like you run the risk that you stored it someplace and wouldn't be able to catch it, I guess. But
yeah, exactly.
Yeah.
That's why. Yeah, if we store somewhere, we cannot catch it. We cannot always catch it. But what are those situations? I'm thinking.
Yeah, and I don't know. It seems to me like this is the as far as patterns in IL go, this is the simplest possible pattern that you could have to look for and recognize. And if we do look for it and recognize it, then we'll catch cases that weren't even using this, right? Like if somebody did a splat, and then gave it to the
Right.
and then passed in the vector, we would want to optimize that too.
Right.
Yeah, I guess the question is, for example, IL during generating IL, we added like splat, and that splat got into register, like PRE moved it out of the loop, so we kind of lost track of it. Right? That's what's the sort of concern. We lost track of the fact that it actually was splat of constant, or like scalar. So that was, yeah, I think that's that way we decided. So what, Devin, what was your argument for that? Like that
Wait, so
it's, if you
so the concern is that having to do the broadcast operation is expensive, and that's what makes the special in form of the instruction more efficient, is that you can skip doing the broadcast.
Yes, yeah.
Okay, so I think personally, if that broadcast has already been done for some other reason, or it's been moved out of a loop, I'm not really worried about the cost of it as it pertains to the shift.
A little bit missed why you're saying for another reason. It was done, it will be inserted all the time, right? By IL generation for this for this
Right. Okay.
code,
So if you
right?
just generate IL and then you generate the
Insert
code,
splat, right?
it'll be there, and then we'll see the pattern, and then we'll generate the good instruction.
Yeah, but
Something else has to happen to make us not generate that, right? Like we don't
putting
just
into register, like putting into some temp, essentially. Then, if you want to track and evaluate, it has to be right in the same tree, right? What if it was put into some temp register? That's splat.
Okay, we could approach it from a different side too, is that it's easy to add, you can't argue against having a shift operation. You can't argue against having a broadcast operation. Together they can be used and recognized to do this shift by a constant thing, if you want it or not. But it's better than adding VL shift const or whatever it gets called, and then realizing that we really shouldn't. Like, it's more difficult to make the decision to take something out like that.
Oh, I see.
Right.
Kind of like
we could make a decision later on if we see that we're missing lots of opportunities to do this vector left shift by a constant or scalar. Then we could add that opcode later and tackle that problem.
That's true. That's true. Yeah. Okay. So let's take it out for now. So let me take a note. Const. We can always add later. Yeah. If you're missing, it's kind of like, I guess. Yeah. I just wanted to be sort of complete as much as possible.
Shall we move on to the next opcode?
So remove const. Okay. So of course. So now shift right, which is like similar, of course. Here again, I will correct. It's just it's sort of like a lambda kind of, right? It's a function. It's doesn't. I need to explain that, and it's each element of BV, but I'll try to explain that.
Right, and then that's going to want to be renamed like for left shift, I think.
SHR, right? SHR. SHR. Yeah, that's kind of, I suspected that we need to rename. And there's mask version, and then const will remove for now. Const version, and then this will be USHR, which is consistent, I think, with what we have. Unsigned shift, right? I think we have USHR, right? So USHR, okay.
Yep, that's right.
Const remove for now. Fine, that's fine, yeah. Now rotate. We don't have any rotate, right? In our IL. Let me check.
ROL or
Yeah, just checking.
We have? Oh yeah, there's ROL, right? Yeah. Okay.
Yeah, like I roll, for example.
We have I roll.
I might be pronouncing that wrong.
not supposed to pronounce that one.
Downhill.
But what is it? It's like integer rotate left. Okay, renaming, sure. Like row.
You only have left, you don't have right. Well, I guess you can.
You don't have right? So it will be ROR.
And there's a long version as well. So yeah, so ROL.
ROL, ROR, okay.
And interestingly, the IL opcodes that we've been mentioning that we want to be consistent with are also the in a lot of these cases they're matching the vector operator's constant name.
Yeah, that's fine. Yeah. It's in the library. Yeah, they use those names. Yeah. I guess I kind of was thinking make it more descriptive, but absolutely, yeah, we can use those short names. So const we remove for now. Yeah, those rotate right, which is also like mask, non-mask and mask versions, kind of similar. So will become ROR, right? VROR, VMROR, range-wise, yeah.
Do we have? I thought we don't have integer rotate right. The way we achieve that operation is negate the second operand and use the arrow.
Mm. But I would say here for vector, I think we need to have explicit. Because most likely there is instruction for that. Or Rahil, what do you think? Like not to have those opcodes?
I guess we would do a vector negation.
Yeah.
Again, I think we need to check if instruction exists. I would rather have, I think, explicit. So what is it?
I mean,
What is it? Negation and what?
Evaluator can take care of that though, right?
But it's again, you know, like pattern, right? Recognition. Sometimes you can recognize, sometimes not. If it's global, kind of in some temp, you already cannot recognize.
I mean, in this case, if you need to insert an extra operation to do the negation and then do the rotation in that direction, in the left direction, I think just for symmetry, we should have two separate opcodes, just so that you don't have to do that. Because they will ultimately map down to different instructions.
But it's the same argument as with the constant, the same argument.
No.
If there, no?
How is that different?
I think that this case is less clear. Personally, I think I would try to lean as much as possible to having fewer different operations that we have to look at and know about and think about and process. But this case seems less clear to me than the splat one.
I'm looking into the Z pops right now. I don't see shift right. There's only shift left instruction, and the nodes
Rotate.
Yeah, rotate left is the only operation that we have. They do in programming notes says that if you want to achieve the rotate right, then provide the negative shift amounts.
Oh,
Well, it's one is rotation.
negative amount. Yeah. Okay.
I'm pretty sure Intel's got both.
So, yeah, so I don't know what majority would like.
I do think that Mark's point earlier about the splat variant does apply to this as well, though, which is that
Incremental.
it's easier to add than to remove. And so we could, you know, if we don't strictly need it right now, we could leave it out and then see if we find a strong motivation to add it later.
Okay, we'll remove for now. All right. And actually we close, const we're gonna remove. A couple more. So v mask, it's compressed specifically on mask. So it's different argument, right? It takes, because we have in OL, we have mask type and vector type. So
yeah. Why wouldn't this be called VM compress?
Oh, it's because you see, it's very different. VM compress, it means compress with mask. Like, well, there is no such thing compress with mask. It's
so the small m at the beginning means to use a mask in the operation.
Yes, like for example, addition. Yeah, addition with mask.
Should the regular compress be VM compress then?
It's a bit different meaning, kind of. Although, 1 second.
Because it always uses a mask, right?
It's always used as a mask, but in a bit different sort of way. Mask, it's not lane-wise operation. VM, it's like for lane-wise operations. Compress is a cross-lane operation. It's a bit different meaning here. It's not like choosing, but VM compress. It's kind of like compress always is with mask, right? separation always takes mask, and it's not lane-wise, not per lane. A little bit kind of different.
But based on what you just said earlier, it would, if it's guided by a mask that you're giving it, then it would seem that VM compress is the
But
name.
then, like VM expand also, we need VM expand. Kind of, I don't have strong preference. Like it's a bit different. It's not a lane-wise operation, a bit different way of using mask. Definitely here, a very different way of using mask. You know, we're expanding. It's not like we're applying. Well, we're applying, I guess, operation in a sense that we're including that element.
So
into
your
the
use
results.
of the small m in the name has, up until this point, implied a lane-wise use of the mask?
Yes, yeah.
And the reason you have some doubt there is because this is a cross-lane application of the mask.
Yes. It's kind of like mask by default. But it's a bit different, I think, meaning.
I mean, a lot of us here are just are seeing some of these and understanding them for the first time. So we're kind of the you're getting a very fresh perspective on some of these opcode names, I think.
Yeah, I can sense that for sure.
Fresh in the new sense, not the sarcastic.
Like, let me think. Yeah, you see, this always goes like V and VM counterpart. Here it's like mask by definition. It needs mask. And it's not like applying to each element in the sense that whether we're going to pick that element, put it into result or not.
Here's just a very high level question about masks that's kind of related to that other stuff that we were talking about, is sort of decomposing in fewer operations, or sort of leaving things decomposed for now. We have these V and VM pairs, but you know, is there some constant mask that we could pass in to the VM variant that makes, you know, basically the plain V version without a mask is that just a special case of the VM one?
Not well. Like mask all set to ones, all elements set to one. Usually it's very different instructions, like depending on platform, but they're quite different. Like, for example, some platforms don't have mask, like, so it's there's some simulation required. So that definitely we need to distinguish for sure.
But all that would be done at the back end. If you, when Devin said the thing about the constant mask, you would just check, oh, it's all ones, so therefore I don't need to use, I have a different instruction for it. I can just use the non-mask instruction for that.
But you see, no, I think it would be, the IL would be looking really complicated. And we don't have vector constants, right? So how we would represent that? We will, V bit count would be VM bit count is 3. This one has 2 children, this one has 3. And for that, we're going to have third child.
And it would be a splat of a constant, I guess.
Oh, no, that's too complicated. No, OIL will be way too complex.
Also, I think the idea that we may lose track of the mask and be able to be unable to match the pattern, I think that has more weight here because you might not even have an instruction to do it with an arbitrary mask.
Exactly, yeah. It's much more expensive. Like say on Power and Z, it's absolutely, different sort of implementation, for mask operation.
Okay, thanks for entertaining my
it
query
was
there.
Interesting idea. So, all right, so we compress, again, I don't have strong preference, but more leaning, I would say, to without M. Just because it takes mask, it doesn't mean it has sort of the same meaning.
Okay. I mean, if it's going to cause confusion with the things that you've already done, like for the masked IL opcodes where it has a lane-wise, if the understanding is that it means a lane-wise, if we suddenly start using it for not, I don't know if that's going to cause confusion with any one.
No, it's not going to confuse. It's simply just a name. Like, you know, Cogen always knows what to do with a particular opcode.
Well, it's more than that. I mean, we want, when people see the name, we want them to understand, like to be able to parse the name and understand what it is. This is a vector opcode. It's got a it's got a mask operation, and you can figure out the type in some cases. So we do want to be somewhat consistent. But I don't know.
Yeah, I think if somebody's unfamiliar with these operations, they're going to have to look up the opcodes, because it's not like, oh, I understand what compress means just off the top of my
They
head.
need
You know?
to, there's pretty extensive documentation here, yeah. People would need to know, yeah. But I guess maybe difference is like if...
So by the way, the Open JDK documentation, I don't think should be the documentation in OMR. We should define the semantics of these IL opcodes within the OMR, be it in the code base or someplace else. I don't think it should be a link to something else.
Yeah, I agree. Yeah, I agree. Yeah, it's just sort of temporary. Yeah, I'll kind of explain it here, copy here. So let me take a note.
Okay, so we'll leave them as is for now, and
maybe leave it for now. I have a feeling it's better to leave like that, because it might be confusing that it's people kind of will think it's something lane-wise. For example, say if platform doesn't have mask operations for this type of, they use select. They do operation and then you select opcode. Here, I don't think you can use the same approach. Select. Okay. No, yeah, it will be different. Yeah, sort of slightly different kind of meaning. All right. So where did we left it? Rotate we know. Const we remove. Compressed specifically for mask. Yeah, I will put more detail, sort of kind of explain semantics here. And to be completely honest, I think, yeah, why there's no expand mask, for example, you'll need to check the mask compress. Why it's slightly different, to be honest. I think the difference was just because of taking mask versus vector. Yeah, I think I think it just basically takes a mask and like compresses all like elements, you know. So it's a bit different again. It doesn't need a mask itself, right? You see, it doesn't need argument mask. So it just compresses them. There's no like false elements in the mask, only like ones. If I remember correctly. So different semantic. So here again, like we don't want to use M because it's different meaning. It's meaning that takes a mask. It's different sort of semantics.
Sure.
So I guess like if you start with a mask, which I'll call M, and then you vcompress, you use it to vcompress some vector V. So you get out the resulting compressed vector, and then this operation on mask M gives you a new mask that tells you, like it's probably the positions in the compressed vector that have been populated from the original vector. Is that right?
No, I think it's just, you see, like here, compress set lengths from this mask. Returns mask with series of n set lengths followed by a series of unset lengths.
Right. Yeah, so that's going to be the lanes that are in the result of the compressed vector that you compress using the same starting mask.
if vector is the same as mask. Yeah, I see. Like if
Right, it's going to be like these are the lanes where we put the data when we do the vcompress using this mask.
wait, 1 second. Basically saying we can again like replace it with
No, I'm not saying we can replace it with anything in particular. I'm just trying to properly make sure that I'm understanding that what the operation does. It seems to me like here, let's say that you want to you have a mask. It's going to pick out, I don't know, every other lane or something. And then you use a vcompress that now you've got a vector with, you know, those lanes that were identified, but they're all together.
yeah.
And then let's say that you want to store that, but you only want to store as much data as you have. Then you can't use your original mask, but you can use the compressed mask. That's where the data is in your compressed vector.
Probably that's basically, yeah, possibly the use of it, how you use it. But otherwise, by itself, it's like sort of relatively. If mask has 5 elements set, maybe not every, you know, like not contiguously, then we will get mask with first 5 elements set. And we can use it, you're right, for that other operation, like it will be equivalent, sort of. It will match that vector, yeah.
Okay, thanks.
Yeah. So what about a name? Like, do you think it's okay? Specifically for mask, it's not masked operation, but it takes mask as an argument and returns mask. Oh, it returns mask. Maybe it should be M mask. Oh, maybe it just should be M compress because we have opcodes on mask. We already have like opcodes starting with M. Some operations, for example, any true, like say, for example, I'm looking right now at the vector opcodes. Any true, it means it returns if any element of mask is true. So it starts with M, not with V. Yeah. Actually, maybe
So
should
you
be.
think it should be just called M compress?
Yeah, M compress. Which
Sounds like it would be consistent with those
V
existing.
compress, yeah, with V compress.
Okay.
Yeah, actually, where is it? Oh yeah, okay. So let's make V mask compress. 1 second, I'll just write down M compress. Yeah, I think it's better. M compress. Okay, great. So now we have that's easier, right? Like it's a vector operation. It's lane wise. It's trailing 0 count. Name maybe again.
I think we have scalar versions of these again. They're named NO, I think, for number, and then LZ or TZ.
1 second, let me see.
So we have like L nulls and I knots.
Say it again. What was the name? You said N.
So here there's I NOTZ. There's a long version, but I mean the relevant part is the NOTZ is number of trailing zeros, I think, and then we also have NOLZ for number of leading zeros. I think that's what these mean.
Yeah.
At least I'm just looking at the fact that these opcodes exist, and
yeah, of course, yeah.
I don't actually I'm not looking at the usage to confirm that that's what they mean, but that's the only thing that I can think that they mean at the moment.
So we have both trailing and leading 0.
Appears to be. I don't think every architecture implements them, but there is a precedent in the naming and the IL for those operations on scalars.
Maybe I didn't get it. Maybe I misspelled it. I'm looking for NLZ.
NO Here, it's November Oscar Lima Zulu.
Oh, got it, got it. Thanks. NO, I missed. Okay, NO. All right, yeah, sure. I didn't know we have such, okay. NOLC. Sure. NO for number. Okay, got it. Leading 0. All right, so.
Well, no, it's not number, it's number of
number of
zeros.
leading 0, NOLC. Yeah, of course, that, yeah, of course, yeah, I just didn't know. So we'll rename this. It's just lane-wise, it has mask version. So I will rename that. And similar, this is trailing, this is leading. So it will be like, yeah, NLOZ and this will be NOT. Do you have NOT? Yeah, NOTZ. Yeah. All right, so that's good, thanks. Yeah, absolutely. Yeah, so just sort of, yeah, first. So I'll rename those. Reverse and M reverse. It's again, it's lane wise. That's why it has like M version. And yeah, it's equivalent to calling integer reverse A for each element. A again, it's like element. It's not anything. It's element of a vector.
So is that a bitwise reversal? Is that what that is?
Yes, it's a bitwise reversal.
Okay. And then the next one is you're actually just swapping the byte. So that's a B.
Do we have something?
Byte swap.
Yeah, we had a byte swap at one point.
Still in here.
Yeah.
Byte swap.
So that's the reverse bytes one.
Okay.
And B swap.
But bitwise we don't have, right?
Don't believe so. I think we did actually at one point. We may have removed it when we pulled the source. But because there were no uses of it at all. So no, so we don't have one right now.
So what should we call it? Like a reverse, maybe bit swap?
Yeah, the existing one for bytes is called byte swap. So bit swap would be analogous.
Yeah, I think so. Yeah, bit swap. Okay. Well, I think we'll need to maybe another review, like when I correct all this. So, okay. Compress bits. I just like calls integer compress on each element, or long compress if it's long. And what it does, I think it just compresses bits of integer long. We probably don't have equivalent for that, right?
So that is that like the vector compress, but bitwise?
It's for each element. It's very different. It's for it's lane wise.
Oh, right. So I know it's
And,
lane wise, but in each lane, like this integer dot compress here, is that it similar to what the vector compress is doing? Where there's a mask that says we have, I'm interested in these elements, and it puts them together.
to be honest, I don't remember. I need to check. This. And what is N here? It's you think it works as a mask? I will need to check that. Probably, yeah, it's similar. Expand bits. Maybe quickly grab. Sorry. quickly checking the class. 1 second. Java integer.
Yeah, it seems like that's what it does.
It does
That
it.
second argument is a mask, and then it collects together the bits that are identified by the mask, by my reading.
But in this case, it's just a vector of interface.
Right, so
Right?
it'll do that on each lane, right? I guess each element of A is data, and then each element of B is a mask, and then. Okay.
All right. So how does it kind of match the name? Compressed bits. Compressed bits. Sounds pretty descriptive, right? Or remove bits. I would keep bits, I think, right? Yeah, we have to, because vcompress has another. Yeah, otherwise it will become vcompress. Vcompress bits.
The scalar instructions for X that do this are, what is it? pdep for bit deposit and px for bit extract.
Yeah. I know in J9 we have some profiling stuff that generates a tree that turns into parallel bit extract, or we did.
Yeah, it is. It's bit extract, of course.
And yeah, do we have an opcode for that?
Yeah, yeah. Let me
What is the opcode?
share that. I'll share it on the issue, but I know that we have the code.
Oh, thank you.
Thanks, Rahil.
It's for expand, right? It's extract, similar to expand.
No, I think extract is compress.
Ah. Yeah, Rahil. Yeah, if we have equivalent, you think it's like the same meaning?
I'll check that it's called bit permute for the profiling that Devin is talking about, but I'll check if the operations are same or not. But I'll comment on this issue.
Oh, thank you. Yeah, okay, great. Yeah. So this is under still sort of design. And I think that's it. So these are all opcodes for now. So thanks a lot for the suggestions. Yeah, I missed some existing names.
So just in terms of the documentation here, what is your plan for describing the semantics of these? I know we don't have a great place to put this in the code just yet, but just given the discussion that we've had on some of these opcodes, and it would seem that we should have a more precise description of what each of these does and have that documented somewhere, either in the code, which is maybe preferable, or in a separate document.
You see, in the code, I was trying to squeeze it in the .enum file, right? But it's too big, like there's description field. It's too much text. That's why I put it outside into that PR.
Too much text, meaning you are concerned about the readability of the enum file?
Yeah. It will take several lines, right? Is it okay? Several lines, the description field?
I mean, I guess it depends, but if the information is useful and we have no other place to put it, and if the presence of comments in that file does not cause any other problems, which I don't think it will, the C preprocessor will just get rid of it. And if it's readable, then I don't think there should be a problem with that, unless others want to raise objections to that.
It's not as though the entries are already compact.
It will be usually takes one line, but yeah, but it will take in some cases will take like 3-4 lines. But I guess yeah, you're right. Why not? It's a comment, right? It's just a comment.
I mean, more
Yeah,
information
actually,
is always better here.
of course, I agree with that. I just somehow felt like, you know, it's usually one line, very brief descriptions.
No. I mean, we need more. I mean, I think that's just like a problem that we have in this project is we need more of this kind of descriptive information there. So, okay. All right. Are there other comments on any of these opcodes? We should get on to Spencer's proposal as well here.
I will update and people can comment, right, in PR.
Yep. Okay, terrific. All right, thanks for taking us through this, Gita.
Thank you. Yeah, thanks.
Good additions to the opcode set here. So.
Thanks.
Okay, thanks. All right, so our second proposal is another IL opcode proposal from Spencer. So I'll let you take it away.
All right. Can I share my screen here? So let me make Keynote look nice before I share it. All right, can see that? That's good. All right, so I guess my proposal here is to take the array compare opcode and split it into two. So a bit of a refresher on what the array compare opcode does. There's three sort of flavors, I guess, of the array compare opcode. There's a comparison one here on the left, and there's between the two, it's not much of a difference. It's more of whether you're returning 1 or 2 or 1 or -1. I might have the constants mixed up here, but not important for the proposal here. And then the other flavor is to return the length. So this one, you kind of return an ordering, some constant that says which one's lexicographically, however you say that word, which one's higher. And this one, you actually return the index of the mismatched element. So yeah, there's already a fair amount of difference there. The biggest problem with this, though, is that it's a 32-bit opcode. When you're comparing lengths here, returning a 32-bit doesn't make as much sense, given that your input length is 64 bits. So to me, it makes more sense just to split this guy off into its own opcode.
So if I can jump in for a second, if you don't mind, Spencer.
Oh yeah.
I just want to point out that currently array compare takes a length that I believe is 32-bit as an input, which is an undue. Oh, does it?
Yeah.
Interesting. The child properties claim that it's 32.
Oh.
So if we're already passing in a long length, then that's great. But if the child properties were correct, then that would be you know, an undue limitation, right? On even these ones on the left. But definitely for the one on the right, you know, you want to be able to compare up to whatever size we have in memory, and you know, you can't return larger than 32 bits. Anyway, I'll let you continue.
Well, that was about it. I guess the one use case that it came up in was in transforming a Java method, vectorized mismatch, which when we're looking at it, it does essentially the same thing as the array compare length, just with some trickery on the return value when you don't find a mismatch. So we can basically translate it into this tree. The only problem is the array compare here returns 32 bits. And since we're passing in our byte arrays and extending, or we're passing in an array of some element and then extending it, that length, to a byte array, we can be comparing more bytes than would fit in a 32-bit length. That's the one use case where this came up. Yeah.
So is the proposal to have an array compare length which returns a uint 64_t?
Yes. Yeah.
Okay.
It would be, I guess, twofold there. Split out array compare length into its own opcode, and then have that opcode return 64-bit instead of 32-bit.
Right. In my view, this is just conceptually cleaner anyway, because the meaning of the result of this operation, when it currently has the array compare len flag set on it, is very different from the meaning, of these variants on the left.
Yeah, I wholeheartedly agree. I think it's a mistake to overload an opcode too much. And believe it or not, this is actually already a simplified version before we went open source the code. So it used to be even worse than this. But yeah, I mean, I support splitting it up into different opcodes. Just makes it cleaner and doesn't trip up people who want to do anything at all with array comp. They have to understand all these complexities otherwise.
Yeah, I think also I'd further than this, although this is not part of the current proposal, is that I think that these two on the left we should do something about it about that too. But for the moment, I think just to get the use case that Spencer's been working on, where we may be comparing arrays whose sizes don't fit in 32 bits. We want to make sure that we can represent that length of the longest matching prefix in bytes in the result. And so there were a couple of possibilities that we talked about, by the way, in terms of making sure that that's representable in the result type. So one would be, so the main thing I wanted to avoid is having the return or result type be dependent on the flag, so that when the array compare len flag is set, then it's going to be long. So that I thought was very, very bad, and we should absolutely not do it. There's the so that this is the main thing that I was trying to avoid when kind of pushing in this direction. Then we could make the result of array compare len be the type of integers that are pointer sized on the platform, but I don't think we have precedent for that. Normally we would have a pair of opcodes, one of which we use on 64-bit and one of which we use on 32-bit. But I don't think it's worth having the weird unprecedented thing or the pair of opcodes for this case. It seems to me that on 32-bit we can just truncate the result, and I think that is sufficient in terms of this operation. But I just wanted to talk about that.
The closest thing to having that sort of 32-bit, 64-bit split is AI add and AL add, right? that there is that example before us of splitting it. But I'm not saying we should do it in this case, though.
Yeah, exactly right. I don't think it's worth it to have I array compare and L array compare len, and then you have to pick which one, and you have to have a property to let you recognize, and
Yeah. Yeah.
So I would prefer that just the length that we pass in always be long, and that the result always be long. And then on 32-bit, we can sign extend the length before we pass it, and we can truncate the length that we get back.
Are you planning on providing the implementation of this opcode on every architecture?
I guess at least everywhere where this operation is already implemented.
Yeah, not every architecture has array compare links supported. I think most of them do.
Oh, there's, so what? So
this operation already exists. It's just that currently it uses the array compare opcode with a flag set to tell us that we're actually doing this operation on the right.
I see. Okay. Got it.
And as an argument for separating to the evaluators, whether you have array compare length or array compare on some of the backends are already quite separate. So mapping that from one opcode with a flag set to two opcodes is pretty simple. Did a test of it, and it took me about 2 hours of just copy and paste.
Okay. I mean, I guess same comment as for Gita about documentation. Please throw that in there, I guess in the enum file, wherever it happens to be, describing what this does.
I have a 10,000-foot question. Is arraycmplen the best name we can come up with for that operation? I mean, I know it started that way, but
it was the best name that we wanted to stop bike shedding with at the time. But now might be a better time to discuss that. Sorry.
Well, I thought that there was a C runtime method function that does this, and actually while you were talking, I was Googling that to find what that was, and I couldn't find one. So, but I was sure there was one that tells you the index for the
first diff index.
Or max common prefix length.
That was just a question.
Yeah, I am open to any better name proposals.
You're a vector variant of it? Okay, I mean, I think there is consensus here that a separate opcode is warranted for this.
So
I guess you go ahead, Henry.
Yeah, I just wanted to pursue briefly what Devin was saying earlier about the two operands on the left, or sorry, the two operators on the left. And I mean, I had been thinking earlier in the year about this topic, and had been thinking about whether all of ArrayComp ought to settle on the ArrayCmplen, and then situations where a 1 or a 2 or a 1 or a -1, or the difference between the last the first element that's different could be implemented in terms of ArrayCmplen instead, and eliminate all the complexity on the left. If people think that's might be worth exploring, I could try sketching out what that would look like.
I don't think it would turn out as simple as one might hope.
Okay.
And it's because these operations on the left are, I think if you look at, I don't think that they work quite as written here. Oh, I guess in C they do, because data races are undefined behavior in C. But we can have data races. And this, A of I, being equal to B of I, and then if it's not, we, this code as written would load them again, which can give different results, right? It can actually give you, ones that are equal now.
Right.
So I think that the semantics of this is more that we load A of I once, we load B of I once. If the results are different, then we return something that tells us in which direction they compare. Without reloading them.
Right.
Trying to rematerialize. But if you wanted to implement in terms of array compare len, then you would be forced to always do that rematerialization.
Right.
So you could get like a weird thing where the array compare stopped because there's a difference, but then when you look, they're the same. And then if you want the proper result, you're going to have to loop.
But there's
Can't
no
you
guarantee that you're
privatize it?
synchronized anyway, right?
No, but can't you privatize your way out of that? Right, you could create a temporary that points at the arguments A and B, and those temporaries stay the same no matter what happens to the field or static value, right? So you always load from this array.
No, that's fine. I don't mean rematerializing the array reference. I mean the array element.
Oh, I see.
So you have no guarantees on that, right? Like if somebody writes code that does an array compare and gets a result back and then loads the values again, they'll be different, or they could be different. There's nothing that's going to protect you from that unless you synchronize it yourself. I don't think there's any real atomicity guarantee that an opcode is giving you, is my point, I guess.
I think that's true, but at the risk of speaking for Devin when he's here and perfectly capable of stating his thought process, I think he's worried about you might get a value that is very weird, right, in this case. Like if you loaded up the array element again after the return has happened and then did some arithmetic, you loaded up the array elements again,
I think we're just
figured out what you want to return, and then updated the value. Something weird could happen that was impossible as per the...
Yeah, so I think we're arguing ourselves out of Henry's proposal, is what I'm getting from this, right? It's asking for the location where the difference is the wrong API, right? If what you want to know is, what is the difference, then the answer should be the difference is this.
Yeah.
Right?
Yeah.
And decomposing that exposes you to problems like we're talking about. And there's no way to fix that by defining the opcodes.
Do either of these array comp implementations map to a single instruction on some architectures? Like
sure hope
Z?
So. The way that would remain the remove the last shred of
especially the 1.2 version of it.
Right. So
I bet that's said, right?
Yeah. So you'd have to, like, you couldn't get that array complen semantics out of it. Like that would be the most efficient way of doing it, presumably, is to use that instruction.
Yeah. By the way, this sort of experience. Sorry, go ahead, Devin.
No, but I do wonder though if these two on the left could be. I mean, these are basically the exact same operation with a slight difference in the encoding of the result. And if we could, reduce that down to we have one of those, and then maybe if we want the result to be a particular way, we do some, a bit of bit trickery or something to
Yeah.
convert it
Yeah.
that then we could recognize, and then we only have one thing.
Yeah.
Or
I
you
mean,
make the
only
two
only
values operand. That's another way you could do it.
Oh
Pass
yeah.
an icons 1 and icons 2, or icons 1 and icons -1, and then it just returns whatever that one is.
Yeah.
And on Z, you'll see that it's the one you want on Z, and
Right. Oh, if the results that I'm looking for are 1 and 2, then hey, that's already what I'm producing. Great.
Right.
Yeah.
Also makes your folding of it really easy if you know the answer, because you got an icons handy, the right icons handy. It may look a little bit weird to be passing 1 - 1s all over the place, but yeah.
I do want to express support for a higher level point that Henry was making, that it's maybe the right time to clean this up once and for all. Like, otherwise, like,
Yeah.
why do it in 3 installments? And I'm saying there was 1 installment before, and yours is the second one, and leave it to somebody else to do the 3rd one. Whatever it is that we want to do, let's just do it now-ish. Now that we've had this discussion, whether it's Spencer who actually does it or all of it or not is a different matter.
Okay. I think I'm happy to agree to that kind of thing, as long as it doesn't as long as we don't consider that to block this first step that I think we can agree on of arraycmplen as its own thing, which will have a long result.
I agree with that mindset. 3 meanings attached to arraycomp is worse than 2 meanings attached to it.
Yeah.
Especially the difference in some bizarre arithmetic.
Yeah.
Right.
So
Okay.
I do agree that also that I want to I would like to see this left side cleaned up, and which is why I mentioned that earlier a little bit, but I wasn't trying to propose that at the moment, and so I haven't given it all that much thought. So I don't know. We have these few ideas so far off the top of our heads, in terms of maybe have one of these as the real one, and we do some bitwise tricks, or bitwise and arithmetic or whatever. And then the other one was pass in the constants. I don't know if we want to try to brainstorm, or try to pick one of those two, or what.
Yeah, I mean, I think historically there was a non-Java product that introduced the array compare that had the semantics, like the top semantics, and then it was Java that introduced the bottom one. There may be some performance implications to that, choosing one or the other. That might be work for one of those projects to resolve, to get better performance out of it if there's additional overhead here. So, but I mean, I agree with we should have an opcode with common semantics. I don't think we should have 2 different implementations, but I think that
all of that sounds like an argument to bring it back for another round of review. I give people 2 weeks to think about it some more.
Yeah, I think so. I don't want to jump into anything here. I mean,
so there are those 2 ideas. The 3rd one, I guess, is just another opcode. Like, blow this apart into 3 different opcodes. I'm not saying that's what I vote for, but
yeah, that it is a possibility, and that we would have some weird like array compare 2.
No.
This is the one that can give you a 2.
Array compare 9.
2v1. Oh no, you can't use bees.
A non-negative array compare. That's,
Yeah, stop.
Well, we can,
Yeah.
Stop there.
okay. All right. So I mean, at
Yeah,
the very
well,
least, we can go ahead with the arraycmplen and
if these two constants are actually in the right position, or if these three constants are in the right position, according to what the code currently does, then the stuff actually compares in the right order if you consider the result to be a 2-bit signed number.
I give no guarantee that these constants are. And quickly type this up without
Yeah,
looking too
okay.
closely.
yeah, I think that needs a separate issue altogether, and have people provide. Like I know Henry's been giving this some thought as well, so I certainly would like to hear his contribution to that issue too. So.
Okay, that sounds good to me.
All right. Are there any more? Because we're getting close to the end here. Are there any more comments for Spencer? Okay. If not, thank you, Geeta. Thank you, Spencer, for taking us through these proposals today. And thanks everyone for attending. And we're scheduled again for 2 weeks from now. See everyone later.
All right, thanks.
Thank you.